Hi, welcome to Oracle CloudWorld 2022. My name is Agahia. I'm a Director of Cloud Engineering with Oracle Cloud. I will be presenting this session with my colleague, Raffi. Raffi, please.
Hi, everybody. Welcome. My name is Raffi Shahbazian. I'm a Principal Cloud Network Architect for Oracle Cloud Infrastructure. I report directly to Agahia. Thank you for the introduction, Cam.
Absolutely. Thank you very much, Raffi. So the session we're presenting today is about top 10 network architecture decisions on Oracle OCI. These are the decisions that every network engineer or architect, when they are architecting solutions on Oracle OCI, at some point need to make. For this session, we're going to start with subnets. We're going to talk about routing on OCI. We're going to talk about different options that you have in terms of connectivity, how to secure those, how to get access to different SaaS services on OCI, how to use NAT as a solution, how to best use network firewalls, how to deploy different load balancers, pros and cons of each. And of course, we're going to end this session by talking about two important solutions, Oracle WAF, which is a web application firewall, and Oracle DNS. First topic to cover is different types of subnets. On Oracle Cloud, generally speaking, you have two options. You can have Oracle public subnets, or you can have private subnets. When an architect wants to design a solution, these two decisions are usually the most fundamental decisions they need to make. You choose a private subnet when you want to have full end-to-end connectivity within your Oracle footprint, or you want to have connectivity between your Oracle footprint and your on-prem deployments. Even you can have access to resources on the internet. But there is a big requirement here that some customers do have, and that is inbound access into your Oracle footprint. If that is one of your requirements, then you need to choose a public subnet. So the choice here is very clear. Two options, public versus private. Public option will give you access from the internet straight into your footprint to your resources having public IP addresses. And here a network diagram exactly shows that solution. On the left, you have a network created in a private subnet where you have a NAT gateway in order to go out and have access to resources on the internet. On the right, you have another solution, and that's using the public subnets. With a public subnet, you can have two-way communication back and forth out to the internet and from the internet into your network. All you need in this case is just an internet gateway. A second major decision that, again, every engineer or architect needs to know and needs to make at some point is routing on OCI. There are two different ways to provide connectivity between virtual networks on OCI. One of them is LPG, or local peering gateways, but the other one is the dynamic routing gateway. With an LPG, it's very basic. You have multiple different private networks, and you want to have connectivity between those. Lower scale deployments, low latency requirements, and that solution works great. You can have connectivity between those two private networks. But we also support a more complex solution, which is like a virtual router, and that's called the Dynamic Routing Gateway, or DRG. With DRG, you basically have a full-blown router. You can have full routing between your subnets. You can have routing between your subnets and the outside world, which could be your on-prem deployments. Here, the decision is pretty clear. If you need a lot of features and functionalities in terms of routing and having control over your routing details, a DRG is a better solution. If you're looking for a small deployment, probably small scale, that's not going to scale to something much bigger, you can easily get away with LPGs. And keep in mind, LPG usually offers better latency for ultra-low latency deployments. Here, a network diagram shows exactly what I was talking about. Two different options. This is the LPG option, and we have different networks, and we provide connectivity between those two using low latency LPGs. Same deployment using DRGs. Again, this is a virtual router and provides virtual routing between the two virtual networks. And as you see, you have the subnets, you have full connectivity between the two. You have also connection via FastConnect to the outside world. In this case, you're on premises. Another key decision that network architects and network engineers need to make is FastConnect versus VPN. That's actually one of my favorite decisions. Almost in every single case, that's one of the very first questions that customers have for us. IPsec VPN has been around for many years. As soon as you want to connect two remote offices or remote office to a hub network in a traditional deployment, the very first option is let's use an IPsec VPN. We carry this over to the cloud generation. Now the cloud, you can have the same kind of IPsec tunnel between your on-premises device, which could be a firewall or a router, and of course your OCI footprints. It's a quick and dirty solution, and it's actually pretty secure. It's right over the public internet, and it can be set up in a matter of minutes. Many customers want to go beyond that. They have higher bandwidth requirements. They need more reliability. They just do not like the nature of the public internet, which is an insecure network, might not be as reliable, might have packet loss, might have higher jitter. For those customers, we have another solution called FastConnect. FastConnect will provide a dedicated solution between customers' network and OCI, and can go as high as 100 gigabits per second. And it's very predictable, so great for higher scale permanent solutions. Decision in this case is, of course, very obvious. If your deployment is something very small, usually proof of concept, and you just want to get things started, VPN and IPsec would work. As long as you have internet connection, you can write over that connection and establish your IPsec tunnel into OCI. But if you need anything beyond that, in terms of bandwidth, in terms of latency or jitter, FastConnect is a better solution. Here, we show you the option to establish FastConnect connectivity using BGP for routing between customer on the right and their on-premises on the left. Customer uses a carrier or some kind of connection fiber into OCI. Once again, this provides higher bandwidth, better latency, and much lower and more predictable jitter. This is the site-to-site VPN using IPsec tunnels. Can be set up in a matter of minutes, but has limitations in terms of bandwidth, latency, and jitter. Definitely not recommended for major and permanent solutions where customers want to connect big OCI footprints to their mission-critical applications. FastConnect Security. That's mostly, well, this question comes up in many cases. As soon as the customer has a FastConnect in place, next question is, how do you secure that connection? We have a traditional way, it's been around for years, and we have another way that came out a couple of years ago. IPsec over FastConnect is a solution that pretty much everyone's familiar with. You can always establish IPsec tunnels between your on-premises device, again, could be a router or firewall, into OCI, and land that tunnel on one of your computer instances. That IPsec tunnel is going to write over your FastConnect and will provide all the benefits of IPsec tunnels with great encryption. Of course, most network engineers know IPsec has a lot of overhead, and it would take a lot of horsepower on the devices that own the two ends of the tunnel. There is another solution, MACsec. MACsec is a layer 2 solution, but at the same time provides great encryption, very high levels of confidentiality if you care about your traffic and how you want to protect it. More importantly, it's not going to take as much horsepower as IPsec does. So you can achieve pretty much line rate encryption using MACsec, and that's a very reliable option. The decision here comes down to what kind of equipment you have and how you want to protect your traffic. This network diagram shows you how to establish MACsec between your OCI footprint and your on-premises equipment. Needless to say, in this case, your on-premises equipment should be able to support MACsec. If it does, again, most cases, you're going to have better throughput than the same solution implemented using IPsec. And this is the traditional IPsec solution. We're running an IPsec tunnel over at FastConnect from on-premises equipment straight into OCI all the way to one of our compute instances. You can download one of many solutions that we have available on a marketplace and deploy it on one of your compute instances. And that will act as the termination point of your IPsec tunnel. That solution was over private peering. This solution goes over public peering using FastConnect. With FastConnect, you have two options, public and private peering. And these two network diagrams shows those two solutions. Connectivity to Oracle SaaS. Oracle has been around for decades, and hundreds, maybe thousands of pieces of software and applications were released by Oracle over the last few decades. Many of those applications are available still in Oracle OCI as SaaS. In order to get access to those services, there are three general ways. You can ride the public internet, get access to those services via the public internet. From your on-premises, you try to access SaaS, and they are available, might be available depending on kind of services, via the internet. There is another way, and that's if you have FastConnect between your footprints, OCI footprints, and your on-prem. If you do have FastConnect, the two options there. You could use public peering or private peering. Both those solutions will provide you with access to those SaaS services. With public peering, very similar to the internet solution. You're going to be able to see those IP addresses for the services, and you can access the services. For private peering, you can deploy something we call the service gateway within your OCI footprint. From your on-prem, you hit the service gateway, and service gateway will open the doors to the world of Oracle SaaS applications. Depending on your requirements, the latency requirements, whether the service is available or not, you can make that decision. Another interesting point here is, although all of these solutions have HTTPS or TLS encryption via the internet, there are customers out there who are still not comfortable with TLS, and they want to see something beyond that, meaning that dedicated connection between themselves and Oracle OCI. In that case, FastConnect definitely is a better solution. If you don't want to use TLS over the internet and you want to have that dedicated connection, you can use FastConnect and go with either option 2 or option 3 that you see here on this slide. You see the internet-based solution here. My customer on the left is trying to get access to a wide range of services via the internet. It's very possible. Second solution, the customer has FastConnect between their network and Oracle. They're using Oracle public peering to get access to the IP address of those services. And this is having access to the exact same services via another cloud construct called the service gateway. From the on-premises, I take the path via FastConnect, I hit the service gateway, and the service gateway opens the door to a lot of services behind it. NAT is another probably important decision that some of our customers at one point need to make. And there are two general ways. You could use our NAT solution, which is our cloud native solution, our Oracle Cloud Construct, or you could download a tool, one of the firewalls or NAT solutions on one of your compute instances, and go with a third-party solution. Two general answers to that question. You want to use Oracle Construct, or you want to deploy your own NAT solution? The answer comes down to the requirements and your functionalities. If you need functionalities, complex functionalities, for example, destination NAT, you have servers within your OCI footprint, and you want the services to be accessible from the public internet. Currently, OCI NAT construct does not support inbound traffic into the network using destination NAT, or one-to-one NAT is not supported. For those complex cases, probably you have to deploy your own third-party solution. But anything beyond that, if your requirement is just doing source NAT outside your network, you want to get out and have access to the public internet, Oracle Construct works very well. It provides source NAT, and it's very reliable, and it can be deployed in a matter of seconds, just a few clicks away. You do not have to maintain any third-party application. You do not have to maintain any compute instances. Of course, you do not have to pay for licenses or the compute instance when they work. This picture shows you how our NAT gateway solution works. As you see, the network on the right wants to have access to the internet, goes through the NAT gateway. This is OCI NAT gateway. Again, very reliable. It's not third party. You don't have to worry about maintaining that device. And the traffic goes out. There is no way for anyone out on the internet to establish a session, to initiate a session into your OCI footprints. But here, you have a third-party NAT gateway. Just like a traditional firewall, you can deploy all sorts of policies on that third-party device. You might want to have destination NAT, source NAT, firewall, all kinds of inspections. It's possible, depending on the application, but you're going to be responsible for the NAT application itself, its licensing, and of course, all the fees of that compute instance. So at this point, I'm going to hand this over to my colleague, Raffi. Raffi, please tell us about network firewalls and the two options that we have here, OCI firewall versus a third-party firewall.
Perfect. Thank you for the first half, Ken. That was really great information. So covering network firewalls. Essentially, OCI Network Firewall, we have a cloud-native managed firewall service that's built on the industry-leading Palo Alto Networks technology. It's a stateful network firewall service that's highly scalable and is built with regional high availability. Essentially, it's a turnkey firewall as a service offering that enables you to immediately take advantage of firewalling without needing to configure and manage additional security infrastructure within OCI. It supports stateful filtering and advanced threat protection capabilities, including custom URL filtering, intrusion detection and prevention, and transport layer inspection. It can be configured to monitor, filter, meaning allow and deny, and generate events and alarms based on certain sets of criteria it matches, such as IP addresses, URL, and application layer metadata. In comparison, you can also deploy a third-party firewall. It's similar to the OCI network firewall. However, a third-party firewall can be used to provide the same features as well. Some of the same considerations for a third-party NAT gateway apply to the third-party NAT firewalls as well. Once again, there could be licensing costs that need to be addressed first. In addition, the overall configuration, whether it's the security posture of the instances to the packet forwarding and the high availability of the service, and all future maintenance of the third-party instances will need to be something to keep in mind when selecting this option. There could be, however, business or security requirements that are drivers to select one solution over the other. Perhaps licensing agreements between you and the preferred third-party vendor are in place, and that can be leveraged within OCI. Alternately, you may need to deploy services rapidly in a very quick manner and start securing them to start consuming cloud services immediately. These types of selections are going to dictate whether you go with an OCI cloud-native firewall versus a third-party vendor firewall. So let's take a quick look at some of the diagrams on how and where to position these firewalls. With the network firewall, we need to position this essentially in a subnet, which is going to be a firewall as a managed service. And for any given host that needs to access the internet, you would point the you would point the route tables to the private IP for that OCI hosted firewall, and traffic will start flowing accordingly. When you compare this architecture with a third-party firewall, you will essentially see that the positioning of the firewalls are essentially the same. Although, again, one thing to keep in mind is the level of effort and the additional cost associated when leveraging a third-party firewall versus the OCI network firewall. Next, we'll have a quick conversation about load balancers. So in OCI, the load balancing service enables you to create public or private load balancers within your VCN. Public load balancer has public IP addresses that is accessible directly from the internet, whereas a private load balancer has a private IP address from the hosted subnet where you deploy it, which is only visible to VCNs or anything attached to those VCNs natively. So what are my options in OCI? Well, we have two different types of load balancers in OCI. One is the application load balancer, and the other one's a network load balancer. Application load balancers essentially offer application delivery, which offer capabilities including TLS offloading, cookie-based session persistence, multi-site hosting, URL path, and advanced layer 7 header-based routing as well. It provides TLS policy control and end-to-end TLS encryption to provide better application security and hardening. The application load balancer service supports three primary policy or algorithm types. We support round robin, release connections, and IP hash. In both cases, whether it's a public or private application load balancer, we're going to act as a reverse proxy, and then we can route the data to any given system that's reachable within the VCN. What we mean by this is connections coming into the application load balancer will not preserve the true client IP prior to forwarding it to its final destination. Whether it's a public or a private application load balancer, we recommend that you deploy these load balancers in regional-based subnets. Similarly, we have a network load balancer. With a network load balancer, we're able to create public and private network endpoints as well. Network load balancers provide slight variations and differences when compared to the application load balancer. With the network load balancers, we're able to support much higher data flows, and also we're allowed to preserve the true source IP of the client accessing the service. This network load balancer, it's designed to handle volatile traffic patterns and millions of session flows, offering high throughput while maintaining very low latencies. The network load balancer is ideal load balancing solution for latency sensitive workloads, and it's optimized for long-running connections that could last from days in order to months. A given flow is always forwarded to the same backend for the lifetime of the connection as well. So a common use case for the private network load balancer is using it as a next hop route target within your VCN for transitive routing, right? Due to the IP preservation of the network load balancers, we're able to route the traffic through this network load balancer as a simple bump in the wire, which is transparent layer 3 routing for most of us. The types of algorithms we support in network load balancing are 5-tuple, 3-tuple, and 2-tuple hashes. If we were to take a quick look at the network load balancing architecture and diagram, we could see on the left-hand side, we'd like to access a network load balancer within OCI from our on-premise location. The traffic will pass through the network load balancer. However, one thing to keep in mind is the TLS security is going to be from end to end, meaning it'll pass through the network load balancer and terminate directly on the backend sets. When we compare this to an application load balancer topology, we pretty much have the same data flow, except this time, the traffic from the on-premise going towards the application load balancer can't terminate the SSL termination directly on the application load balancer, and we could further re-encrypt and pass it to the backend sets. Alternately, we could pass through the application load balancer and go directly to the backend sets for end-to-end at the TLS termination. The next topic we'd like to cover here is web application filtering. OCI Web Application Firewall service, it's a regional-based and edge enforcement service that is attached to an enforcement point, such as a load balancer, whether it's an application or a network load balancer. WAF is going to protect our applications from malicious and unwanted traffic, both from the internet or from the on-premise locations. So what are my WAF options in OCI? Well, there's two different types of WAF policies that we can leverage. One is referred to as an edge policy, while the other one is referred to as a WAF policy. Edge policies are configured at the edge of OCI and your VCN boundary, and is configured within your tenancy, whereas WAF policies are integrated with OCI's application load balancing service. Traffic traversing through an edge policy will be proxied using OCI's WAF public CIDRs towards its destination, which is referred to as an origin. Origins can be either an IP address or an FQDN for an application or a network load balancer. Edge policies will terminate TLS connections, inspect, and re-encrypt traffic prior to sending it to the point of origin. You can further secure Origin's security lists or security groups to only allow connections from the edge WAF CIDRs, because we are proxying the traffic from the edge WAF CIDRs towards the destination. These ranges are publicly accessible, and they're published on our Oracle's website. Some of the configuration options we can leverage with WAF edge policies include origin management, bot management, WAF protection rules, access control rules, threat intelligence, and layer 7 DDoS mitigation. For example, multiple origins can be defined for a WAF policy using the same origin group. When we do something like that, and we have at least 2 origins configured, we will start load balancing the traffic back to origin. In comparison, a WAF policy is now available and can be directly applied on application load balancers. This is used to secure traffic that is not coming in from the internet towards your private application load balancers, typically from an insider threat. The WAF enforcement on the application load balancer further strengthens the security posture of your application, and it protects them from a common wide of web vulnerabilities, both, again, from internal and external intruders. Some of the services offered within the WAF policy include firewalls, access controls, rate limiting, and further protections for the web application firewall. Here, we can see the positioning of the web edge WAF policy. Again, this resides slightly outside your VCN boundary. However, it's configured within your tenancy. We could see the consumer is coming in from the internet, and the TLS encryption will take place up until the WAF policy. In the WAF policy for the application load balancers, this can be used to protect against insider threats. Here we have data coming in from the on-premise networks traversing over FastConnect through a dynamic routing gateway, hitting an application load balancer. Here on the application load balancer, we have a WAF policy bound to it. Prior to the data being sent back to the backends, we will inspect this traffic before sending it across. This helps us protect any traffic that could be potentially malicious from an insider threat. Finally, we're going to cover DNS. The OCI DNS service offering, it allows you to manage DNS to scale. Some of the standard features we offer by OCI DNS are private DNS zones, private DNS views, which are essentially a collection of private DNS zones. We offer a full-blown private DNS resolver for within the VCN, and also within the resolver, we're able to leverage what we call forwarding and listening endpoints. These will be useful whether it's cloud native or hybrid DNS solutions. If we were to take a look at the options to configuring the infrastructure, in both cases, whether it's cloud native or hybrid DNS, the OCI DNS service is a necessary component to the infrastructure success. In the cloud native approach, the OCI DNS resolver for the VCN will allow you to resolve host names for instances within the VCN. It would also allow you to resolve host names for systems within other VCNs using either private DNS views or leveraging the forwarding and the listening endpoints. Similar to a cloud-native approach, a hybrid DNS might be needed to resolve VCN host names from on-premise locations, and likewise, we may want to resolve on-premise locations by way of the VCN. In both architectures, we're going to leverage either private DNS views or forwarding or listening objects. Let's take a quick look at the diagrams and the architecture for a cloud-native perspective. Here we have on the far right side the OCI region, and what we've essentially enabled is anything to resolve the Oracle VCN.com. It's going to either leverage private views or it's going to forward traffic to another VCN's listening node. From the far left side, if the on-premise locations wanted to resolve DNS names within OCI, you could leverage your on-premise DNS servers and put conditional forwarding rules and forward the traffic to a listening address within OCI. Very similar in a hybrid DNS approach, we could take the DNS queries from the on-premise side, once again, forward them to a listening object or listening address within OCI to resolve the Oracle VCN names. And likewise, we could leverage private views or DNS forwarding and listening addresses within OCI to be able to resolve local VCN or inter-VCN FQDNs. And once again, we can resolve on-premise FQDNs by putting a conditional forwarding rule towards your on-premise DNS servers to be able to resolve your on-premise DNS locations. This now brings us essentially to the end of our slides. We covered 10 key topics for network architecture decisions in OCI and the different methods to address these solutions. We hope you found this short video informative. Thank you for listening. We sincerely appreciate your time.